All right, everybody. Yes. So hello, everyone. Here we are with another video in another lesson with Amanj. So today in this video, we're going to talk about the first lesson of chapter 4. That it is definitely new. Like you have never studied it, you have never seen it in previous graders. So it is completely new. All right. The title is Exponential Function, and this chapter consists of 4 sections. So each one of them is very important for the actually upcoming grade, especially for grade 12. So as a suggestion, I strongly suggest you to watch and to follow these videos carefully, to take care of them, especially section 2 and 3 and 4. The first section is just like an introduction to exponential function, and let's just go inside it. All right, exponential function, growth and decay. In the very first section, we're going to talk about 2 types of exponential function. The first one is growth and the second one is decay. We are going to find out what is the exponential function and what kind of exponential function is growth and which one is decay. All right. So basically, regarding to exponential function, the thing that you need to know that recently we had like variable powered by numbers. Regarding to this, we had some rules in chapters of powers, and you study it. Like for example, what I mean by that, you study something in previous grades that if we had like x powered by 6. Just change the color to white. Let's say x powered by 6 multiplied by x powered by 7. In that case, we just keep the x and add the exponent. All right. But that was about powers. Right now we are dealing with function. So function is a little bit different. Like the things that are required to do in function, they are definitely different than powers. So an exponential function is a type of function in mathematics expressed in the form of f of x equals to b powered by x. That is the general form of exponential function. All right. So that b is a number and x is a variable. So x can be anything because here it says that x is an independent variable. That's why x can be 0, x can be positive and negative numbers. Decimals, fractions, anything. That's why later on we are going to just find it out that domain of exponential functions are all the real numbers from negative infinity to positive infinity. We will deal with this a lot during this chapter. So right now we know that the general formula is b powered by x. So instead of b we have got numbers and x is an independent variable. So b is a real number. There are some conditions regarding to b that we need to take care of them. b is a real number that is greater than 0. So since it says that greater than 0, it means that b must be positive. All right? But as well as it says that not and should not be equal to 1. Bash. If it is not equal to 1, there will be 2 situations, 2 cases. Either the number is between 0 and 1, or it's going to be greater than 1. So, if the number is between 0 and 1, in that case, we are going to call this exponential function decay exponential function. And if the base was greater than 1, imagine if we have these 2 cases, just take a look at it carefully. If you have f of x equals to 0.2 powered by x, at the same time, if you have f of x equals to 2 powered by x. So if we have 0.2 powered by x, in that case, the function, we call this function exponential decay. But if you have got this one, since the base is a number greater than 1, then we are going to call it exponential growth function. But remember that base must be greater than 0, which means should not be 0. And at the same time, it should not be equal to 1 as well. Why? Because if it is equals to 1, so we are going to get the same value for every single x. Imagine if we have f of x equals to 1 powered by x. So whatever is x, the result always become 1. Why? Because 1 powered by anything, it's equal to 1. Therefore, in that case, we are going to deal with a constant function, not exponential function. So take care of this kind of conditions that it mentions for the exponential function. So here is mathematically the definition of exponential function. F of x equals to b powered by x, and b must be positive, as well as b should not be equals to 1. Let me just check whether the camera works properly or not. Yes, actually it works. Okay. I hope that you can see the screen clearly. All right, domain is all the real numbers. Remember from the previous topics, we discussed about domain and range a lot for some other specific functions like absolute value functions, quadratic functions, linear functions, constant functions, quarter functions, cubic functions as well. We said that the only thing that it is common among these functions is domain depends on x values and range depends on y values. Since it says that x is an independent variable, so it means x can be anything. Since x can be anything, so domain is fixed for exponential functions. So don't forget this, please. Domain of all the exponential functions, no matter they are decay or growth, is always all the real numbers. Okay. And the range is something that is going to make problem for us, because the range will change based on the function. All right. So range is from 0 to positive infinity according to this parent function. As you can see here, the graph. The smallest x is negative infinity, the greatest x is positive infinity. Remember, this graph goes on without any bounds, and it goes on to right side without any bounds. So that's why it's from negative infinity to positive infinity, which is all the real numbers. As well as range is, look, range is, that is the y-axis. Look, this is the y-axis. So the y-axis, and here is the x-axis. So based on the y-axis, what is the smallest y? It's exactly something above, a little bit above 0. Like it's never touched 0. It's never crossed 0. That's why we are going to say that range is from 0 but open interval. Why? Because it's not going to include 0, right? To positive infinity. Because the graph goes up to positive infinity. Since it goes up, so based on the y-axis, we are going to say that, we are going to demand that the range is from 0 to positive infinity. That is regarding to the parent function of exponential function, which is b powered by x. But we have got some interesting stories. In the upcoming slides and sections, we will see them. All right. Great. So far we know that exponential function is a kind of function that's a number raised by a variable. So the number must be positive and it should not be equal to 1. So there will be two cases. Either the number is greater than 1, in that case we are going to call it exponential growth, or so whenever the x increased, the value of y increased too. That's why we call it its increasing function. So in another term, we call it exponential growth. How about exponential decay? FB, which is the base. FB, which means the base, is between 0 and 1. In that case, we are going to call it exponential decay function, which means from left to right, the graph would be decreasing. Always, we are going to analyze the behavior of a graph from left to right. If it was increasing, we are going to call it exponential growth. And if it was decreasing, we are going to call it exponential decay. Perfect. What else do we, okay, there is a note here. Let me just mention it. We already are familiar with this note. To draw a graph of an exponential growth function or decay function, assign values to x and find the corresponding values of f of x, which is the table of values method. we are going to make a table, make some inputs, since it says that x is independent, so we can give any inputs to our functions. That's why we always use 5 famous inputs, which they are like -2, -1, 0, +1, +2, in order to graph a function. These 5 inputs are enough to make the graph of that function. Perfect. Here are the graph of those 2 cases that we discussed about it. If we have an exponential function in the form of f of x equals to, that is the general form, like the most correct one, form of like exponential functions. Sometimes we have got like a coefficient, just like a. As an example, we can say that when, let's say f of x equals to 0.55 powered by x. This 0.5 is a coefficient and it has nothing to do with domain and range, but like it changed the graph, the values. Whenever we power 5 by the x, at the end we need to multiply it by 0.5. So the values of y will a little bit change. All right. So if we have exponential growth from left to right, guys, don't forget to go from left to right, because this is a rule, like in mathematics, since math starts from left to right, so we need to respect that rule. And to check a graph, the behavior of a graph, we need to just go from left to right. So from left to right, as you can see, the graph is increasing. That's why we are dealing with exponential growth. And in this case, since like from left to right, the graph is decreasing. That's why we are saying that we are dealing with exponential decay. Perfect. All right. So there is a real question here. It says determine whether the function represents an exponential growth or exponential decay, then draw its graph. How are we going to answer this question? First of all, the graph is not given. So according to the base, we need to decide whether it is growth or decay. So let's just do it. The base is 1.3. So 1.3 is a number greater than 1. I hope that you have no problem with this, because when I ask this question, some people believe that 1.3 is less than 1. But 1.3, in fact, it is a little bit greater than 1. Since it's greater than 1, so we are going to say that that graph is exponential growth. That is regarding to the type of the exponential function. But how about like graphing? So we said that we are going to use table value method, which is a table like this. Your teacher might give you in the exam, but if not, that's not a big deal. So you can just make it by yourself. X and Y, 1, 2, 3, 4, and 5. We said that we need 5 inputs. So let's just put those 5 inputs. So 0, 1, and 2, -1, and -2. Right now, you can use calculator, as well as you can use your calculation skill. In case if you want, you can use calculator. If not, just follow me. How are we going to do this question? So 1.3 powered by 0. 1.3 powered by 0. Anything powered by 0, it's equal to 1. Isn't it? 1.3 powered by 1, anything powered by 1, it's equals to the same thing, 1.3. 1.3 powered by 2, 1.3, sorry. 1.3 powered by 2, it's just like 13 times 13, or 13 powered by 2. Even if you didn't know it, so you can just do it like this, 1.3, sorry, 3, all powered by 2, so it's equal to 1.69. So 1.69. All right. How about from the left side? So 1.3 powered by -1. So it's going to give us something like, look, 1.3 powered by -1. So it's equal to 0.76. 0.76. I hope that you can see it. Like the bottom of powering, it's this one. It's just like a Kurdish 8, so you can just use it. All right. So 1.3 powered by -2. And look, I hope that you can see it. 1.3 powered by -2. So So we are going to get 0.5 or 59. 0.59. Perfect. So if you want to graph this, we need to just make a coordinate plane and plot those points on this coordinate plane. So let's say if we have 0, the easiest way is just like something like this. Look, at 0 we have got 1. So imagine here is 1. That is the point. At 0, y equals to 1. So the location of that point is going to be 0 and 1. And at 1 we have got 1.3. Imagine here is 1.3. So here is going to be the location of that point. And 2 and 169. So 2 is here. 169 is above 1.3. Let's imagine it's here. 1.69. So somewhere around here. Perfect. And for -1, we have got 0.76, which is lower than 1. So let's say here is -1. So 0.76 is almost around here. So here is the intersection. The intersection of x and y would become the location of that point. Be careful. -2 is here. And for negative, we have got 0.5, which is almost here. So at the end, we need to connect these points. So if you just connect it, be careful. It's a kind of curve, not a straight line. Be careful. So as you can see from left side, it goes to -infinity. From the right side, it goes to the positive infinity. That's why domain is all the real numbers. But the range is, look, this line is going to come closer and closer to the x-axis, which is 0, but it's not going to touch 0. Never and ever. That's why it's from 0, but open interval. It means 0 is not included until it goes up to positive infinity. That is, let me see whether it is clear in the video or not. Yes, it is. Perfect. This is how we are going to deal with the graph, like how to graph an exponential function and the stuff like this. How about this one? The same title, the same thing, the same story, but this time we are dealing with something like a different base. According to the base, 0.2, it is a number between 0 and 1. So since it's between these two, we are going to just claim that it is an exponential decay function. It is exponential decay function. Okay, so we need to draw a table in order to graph it. That is a table. X is here, Y is here. So 1, 2, 3, 4, and 5. So 0, 1, 2, -1, -2. Just substitute these inputs into the function. You are going to get the value of Y. So number powered by 0, it's equal to 1. Number powered by 1, it's equal to the same thing. 0.2 powered by 2, it means 0.2 times 0.2. So we are going to get 0.04. 0.2 powered by, sorry, there was an interruption. So we are going to get 5. All right. As well as if we have -2, so which means like if we power 0.2 by -2, we're gonna get like 25. You can just use calculator. 0.2 powered by -2, so it's equal to 25. The result is 25. So the graph would be something like this. Let's just plot them. All right. For 0, we have got 1. Let's say here is 1. For 1, we have 0.2. For 1, we have got 0.2 almost here. Let's say here is 0.2. And for 2, we have got 0.04, which is lower than 0.2. So somewhere like this, almost close to x. So this is the point. For -1, we have got 5. So for -1, we have got, let's imagine 5 is here. So the point would come to here. And for -2, we have got, of course, 25. So for -2, we have, let's say 25 is here. Well, it should be above. So here is 25. Then finally, what is the final step? It's just like connecting these points. So let's say from here, it's just going to up. And as you can see, from left to right, that graph is decreasing That's why we are dealing with a decay exponential function. And from left it goes to negative infinity, from right it goes to the positive infinity. That's why domain is all the real numbers, and range is from 0 to positive infinity. Later on in the upcoming videos, I would make like finding a domain and range easier by studying transformation methods. There are some notes over there that if you study them, that's going to make everything easier. So what if we have got this example? Let me just see the next one. Okay. This one, there is a coefficient. There is a coefficient with our exponential function. First of all, according to the base, it's greater than 1. So it's going to become an exponential growth. That is the answer of the first question. The second one is then draw its graph. So directly we need to create a table, something like this. So here it's going to become x, and here it's going to become y. 1, 2, 3, 4, and 5. 0, 1, and -1, -2. So just substitute these values into the function. The process, the steps are all repeated. So be careful here a little bit because we have got a coefficient. So 5 powered by 0, it's 1. 1 times 3, it's equal to 3. Don't go and multiply this 3 by this 5. They are different terms. You cannot multiply them and write 15 powered by x. No, if you write this one, your teacher is going to give you a beautiful 0. Be careful. Perfect. So 5 powered by 1, it's equal to 5. Multiply by 3, it's equal to 15. 5 powered by 2, it's equal to 25. Multiply by 3, it's equal to 75. 5 powered by -1, it's equal to, I guess, 0.2. Multiply by 3, it's equal to 0.6. Yes, 0.6. And 5 powered by -2, I guess it's equal to 0.03 or 0.04. So let's just do it. 5 powered by -2, it's equal to 0.04. Multiply by 3, it's equal to 0.12. 0.12. Perfect. Now we have got our points. The only thing that left to do is just draw a coordinate plane, and let's just draw this graph. For 0, we have got 3. Imagine here is 3. So here is going to be the point. For 1, we have 15. So here, if here is 15, here is 1. Here is going to be 15. Something like this. And for 2, we have 75. Imagine here is 2, and let's say here is 75. So the graph increased like sharply. So here is the point. For -1, we have got 0.6. So let's say here is -1. So 0.6 is somewhere around here. For -2, we have 0.12. For -2, we have 0.12, which is lower than this. So here, let's say. Okay. So finally, we are going to just connect these points. As you can see, we are dealing with a growth exponential function. There is a mistake from some of you guys. 0.6 and 0.12. You feel that since it's 12, it's bigger than this 0.6. But in fact, 0.6 is bigger than 0.12. Why? Because go back to the previous grade 5 and 6. To compare the decimals, we need to line up them. So 0.6, 0.12. This one has 2 digits, but this one, there is 1. So we need to just line up them and with equal digits, decimal digits. So here, 0, 0, 0.6, and 1. So of course this one is bigger. That's why 0.6 is higher than 0.12. And that is the graph of this function. I hope that it is understandable and clear. Take a photo, take a picture, and see what we have done. All right, the next question is the same thing, but only the numbers are different. So the coefficient is 0.1. and the base is 0.5. Since the base The base is 0.5. It's a number between 1 and 0. So we are going to say that it's an exponential decay. And then make a table, then coordinate plane, then graph it. But be 100% sure it is a decay exponential function. So the graph must be decreasing. And the last one, I will do the last one. I will leave that question for you guys. You can just do it and test yourself whether you know it or not. So here, 0.9 powered by x. Let's just do it. Since the number is between 0 and 1, so the function is exponential decay. Great. So the next thing that we need to do is make a table. That is our table. Here is x and here is y. We need 5 points. 1, 2, 3, 4, and 5. 0, 1, 2, negative 1, negative 2. Substitute it into the function that we have. Yani 0.9 powered by each one of these inputs. Like anything powered by 0, it's equal to 1. Anything powered by 1, it's equal to the same thing, 0.9. 0.9 powered by 2, it's equal to 0.81. Which means 0.9 multiplied by 0.9, so it's equal to 0.81. I'm not sure about 0.9 powered by negative 1, so let's just use our friend, which is our calculator. So 0.9 powered by negative 1, it's equal to 1.111 repeated. So 1.1 repeated. As well as 0.9 powered by 2, it's equal to, negative 2. 0.9 powered by negative 2, we are going to get 1.23. Perfect. So right now bring these points on coordinate plane. Let's just do it. So at 0, we have got 1. Imagine here is 1. 1. At 1, we have 0.9. So at 1, we have got something lower than this one. So let's imagine it's 0.9. So here. At 2, we have 0.81. So here is 2. 0.81 is lower than 0.9. Be careful. Because in fact it is 90. So 81 is smaller than 90. So 0.81 it would be like lower than 0.9, almost over there. And at negative 1 we have got 1.1. So if here is 1, 1.1 would be higher than 1. So almost here. And if we have negative 2, so for negative 2 we have got 1.23, which is again higher than the one before it. Okay? Which is here. So let's say this one is 1.1 and here is 1.2. So here is the point. So the graph would be very interesting. Let's just use white. Okay. This one is going to be something like this. Yes, this is going to be the graph of this exponential function and the way that we solved it. So it's basically exponential decay from left to right. As you can see, when we move, the graph is like slowly decreasing. Okay, that is regarding to the exponential growth and exponential decay. Let's see what else do we have. Okay, so here we have got something else that regarding to exponential function, we can find growth and decay using a constant percentage rate for growth and decay with the following formula. There is a formula here. I got this one from your book and I differentiated with myself. So imagine if you have got like a property or something that we sell or we buy. This is related to our real life. And we are wondering whether after some years, like a certain years, let's say 10 years, 20 years, 5 years, 7 years, 1 year, 2 years, whatever it is, how much we are going to, like what is going to be the price of that thing that object that we have after that amount of years. So it depends on the thing that we have. Either the price will increase or will decrease. If it increased, we are going to deal with an exponential growth annually. And if it decreased, we are going to say that we are dealing with an exponential decay. Perfect. If I want to just be more clear, there is a formula here. F of x stands for final amount of price that we are looking for. Okay? A equals to A. A is the initial price, initial like amounts. For example, these things that we have, of course, whenever we buy it, so that price would become the initial price, initial amount of the price of that object, multiplied by a bracket. Inside our bracket, we have got 1 plus minus R. 1 is a number. R stands for the percentage constant rate. For example, we will say that, okay, each year it will be increased by or decreased by 3%, 2%, 5%. I mean, the price will increase or decrease. All powered by X. X stand for the number of the years or for the time period that we have. Perfect. So, how about this plus and minus? If we are dealing with growth exponential, so we are going to plus it. If we are dealing with decay exponential, we are going to use negative, which is minus. But remember, the percentage constant rate, it's going to be given in percentage form, but we need to turn it to decimal form. Yani how, mister? Imagine if it says, okay, the price will be decreased annually by, let's say, 4%. So we know that 4% means 4 per 100. So 4 per 100, if you just turn it to decimal, it's going to become 0.04. Tamam? 0.04. That is how we are going to turn percentage to decimal. Perfect. Okay, there is a question here. It says, Delshad bought a manuscript in 1980 for 10 dinars. It's a question from your exercises. The price increases annually by 5%. Bash. Be careful. 10 dinars. So he bought it for 10 dinars. That is A, the initial amount. If the price increases, it says increases. So we are dealing with growth exponential. And the percentage constant rate is 5%. So 5% equals to 0.05 in terms of decimal. What will the price of the manuscript be after 20 years? So 20 years is the number of X. What was the formula? Can somebody remind me? Yes, perfect. So f of X equals to A1 plus R. Why did I use only plus? Because it says it increases. The price will increase. So since it's increased, we are going to use plus. Powered by X. X is after 20, let me just write X. X. That is the formula. So f of X, let's just replace the things that we have. A is 10, 1 plus 0.05, all powered by 20. So finally we have got like 10 multiplied by 1 plus 0. Look, 1 plus 0.05, it's equal to 1.05, powered by 20, it's equal to 2.6. So 2.6. 10 multiplied by 2.65, let's say. We need these two in order to write the final result as a decimal. So 10 times 2.65, it's equal to 26.5 dinars. So it means that after 20 years, the price of that manuscript will be increased and will become 26.5 dinars. Okay, so in the beginning it was 10 dinars. It's increased like annually by 5%. After 20 years, the price would become 26.5 dinars. And it makes sense since it says that it increased. So of course the price should increase. The next question, we said that Harem bought a car at one of the exhibition for 16 million dinars. Its value decreases. So this 16 is the initial price, which is A. And then we have got decreases. So we are dealing with decay. So inside our parenthesis, we are going to use negative, which is minus 3%. So it is R what will the price of the car be after 5 years? So that 5 years is the amount of X. It is the amount of X. Perfect. So right now we are going to write the formula f of x equals to a1 minus r powered by x. For those who were not in my classes, they can just listen to this video and watch it, and then they will learn it. What are we need to do here? What do we need to do here? So it's A is 16 million. That is 16 million. Multiply by. Inside our bracket, we have got 1 minus. The percentage is 3%. So 3% in terms of decimal equals to 0.03. 0.03 powered by 5. So basically, we have got 16 millions. Multiply by 1 minus 0.03. 1 minus 0.03, it's equal to 0.97. Powered by 5, it's equal to 0.85. 0.85 approximately. Otherwise, it has some other digits. So basically, it equals to multiplied by 16 million. So the result would become 13,739,744 let's say 41. That is the exact result, million, by the way. So after 5 years, Harim's car that he bought it after 5 years from 16 millions, it would become its price will become 13 millions by decreasing annually. That it decreased. I mean, the price of the car decreased annually by 3%. So finally, it's gonna become 13,700,000. So if I ask you to round this answer, so you can just say that approximately it equals to 14 million. Because 739 is bigger than the half, which is 500. So we are just going to round it up. And simply we can say that, okay, in 5 years, it's going to become like 14 millions. That's why it decreased. And we are dealing with a Decay exponential function. It actually mentioned it in the title of the question. So let's just go to the next slide, whether we have got something else. Yes, this is going to be the final question, if I'm not mistaken. Yes, of this lesson. I hope that everything is understandable and clear. So Huner bought a new car again for 16. So I will change this one because it's different. I got it from the book. So it's 36 millions. All right. 36 million dinar. Its value decreases. So decreases by 2%. So decreases means decay. That is the A, the value of A. And here is the value of R. So it says it has two parts, part A and part B, this question. Write an exponential function for the decreases. So for these decreases, so f of x equals to A1 minus R powered by x. So we can say that A is 36 million. Multiplied by 1 minus R is 0.02. I hope that you understand where did I bring it. 2%, if you turn it to decimal, it's equal to 0.02 powered by x. We don't know what is x. So that is the function that the question asked for. 36 millions multiplied by 1.0.02 powered by x. Then in the second part, it says that what will the price of the car be after 5 years? It means x is 5, so find f of x. And just find it out. 36 millions multiplied by 1 minus 0.02, it's equal to 0.98 powered by 5, because 1 minus 0.02 it's equal to 0.98. Let's just do it. 0.98 powered by 5, it's equal to 0.903. Multiply by 36 million, so it's equal to 32 million. So 32 millions 541 148.68. That is the result the price of the car, of the Honor's car, after 5 years, that its original price was 36 millions, and annually the price decreased by 2%. So in 5 years, from 36 millions, it's going to become 32,541,148, and it decreased. And this is the end of this section. So in this section, basically, we got familiar with the exponential function and the condition of the base. It should be positive and not should be equal to 1. So it makes two cases. If it is between 0 and 1, we are going to just call it exponential decay. If it is greater than 1, it's going to become exponential growth. Then we solve some questions regarding to this matter, and then how to graph it, find its domain and range, remember it. And then finally we got to this kind of questions, which is it's related to our real life, finding growth and decay, amount of a price of something that we have after some years. I hope that you got benefit from this video. Watch it, note everything down, and repeat the watching it. So see you in another video. Take care of yourself.